Good morning. I'm Kevin Bates. I am talking about some exploratory analysis and machine learning for county level home prices and economic factors that influence those in the United States for the time period of 2010 to 2017. So the project background is the core of this project is that affordable housing throughout the country is a very hot topic. And so some of the key stakeholders who might be interested in understanding causal links between median home prices and economic indicators could be individuals who are looking for affordable houses, companies that might want to locate to areas where affordable housing is paired with highly skilled labor, and governments at the federal, state, and local levels who would be interested in crafting policies that could develop growth or kind of alleviate some affordability issues in their particular regions. And then, what really drove me to pick this project is that it's a capstone project for Data 670, and I would like to know more information about other locations other than where I'm currently located to relocate to in a future timeline. I wanted to understand the links between strong economies and median home prices on a county level. So the project scope is that I will collect 4 data sources. A primary data set will be a data set called Zillow Home Value Index, and this index is a value that Zillow, the real estate company, puts out that is the median home price for a given county for a given year. That is a continuous number, and it's for a majority of the counties in the United States. This data set will be merged with 3 additional data sets. They are 2 that come from the Bureau of Economic Analysis, and that is a data set that describes county level GDP for a variety of industries. The next data set would be county level economic profile reports. I have detailed descriptions later on in the slides, but this talks about per capita income, the types of income that come into the county, such as retirement, savings, pensions, median wages, and several other economic factors. And then to kind of bridge the gap between those 2 data sets, the USDA has compiled a county level list of population along that include births, deaths, and migration for a given county for the time period looked at. Once those data sets were chosen, I needed to clean and shape them. So almost all of those came in a very non-friendly format in terms of multiple year records on a single record row, and reshaping that was kind of a chore because not until I cleaned them would I know if I had enough data to actually run this analysis per the 20,000 record requirements that this project has. And then finally, for the project scope, I'll develop models to predict the median county housing pricing using continuous economic variables from those 3 sources mentioned above. So for the literature review, there are tons of non-peer-reviewed sources that describe the increases in average home prices across the nation. It's a topic that hits the front page of the New York Times, the Los Angeles Times fairly regularly. So there's a lot of non-peer-reviewed data. There is some peer-reviewed literature, and you get some not necessarily conflicting or overlapping identities, but a particular paper identified that positive immigration into a region is associated with increasing house prices. So if lots of people want to live one place, that'll drive up the average price of housing throughout the county. Additionally, high income locations may have disproportionately high housing prices, and that can be a factor that reduces migration into a specific area. So it like everything with economics, it's complicated, and so there's lots of overlapping factors, which will really be for the scope of this project is one of the limiting factors, and such that there's an infinite number of variables that can be identified and correlated, and narrowing those down into an appropriate level is really the crux of the challenge of getting a good analysis. So for KPIs, the total number of counties with complete housing, economic, and data for the time period I'm looking at. So basically ensuring that we have enough data records for this project was actually one of the first milestones that I need to accomplish. To hit the 20,000 goal, you need about 7 to 8 years worth of data for approximately 3,000 counties. And not only that, not all the data sets that I had were guaranteeing that they had the same counties in them. So that was being able to resolve that was a crucial issue. I will be interested in the lowest housing price to total GDP ratio, just as a good sense of how much where is the crux of the link between GDP and house prices. We'll be looking for counties with the greatest delta between 2010 and 2017. This is positive and negative deltas for house price increases, GDP, and population change. I'll be looking for any industries that stick out um, as being disproportionately effective, or sorry, to affect GDP disproportionately for a given county. So you might be looking at like is the tech sector of San Francisco driving that county's GDP disproportionately compared to say the middle of Wyoming. And then overall, the scope of this project is to build machine learning predictive models. So the accuracy of those machine learning models will be a KPI that helps judge the effectiveness of this project. Some predictions and conclusions. I expect that I will be able to develop a prediction tool for median housing prices. There's enough data in this that something should come out of the models. Whether or not it's useful or not, I would like to think that it will be, but we'll have to see when we get there. I will be interested in predicting. I predict that areas with high housing prices will have higher economic numbers, so stronger GDP, most likely higher migration ratios, and yeah, and then areas with depressed GDP will see lower housing. So if nothing's really going on economically, nobody's going to be looking to move there, and you'll see low houses prices. I do expect to find some interesting outliers of house affordability that stems from specific industry support. I talked briefly about San Francisco. However, when I started this data analysis, I did find that turns out that Bill Gates actually throws off the average of the county that he lives in. So the county that Bill Gates lives in, is Tucson, Wyoming, and that the average income for that county is the highest in the nation at $220,000 per person per year, just by the fact that Bill Gates lives there with about 22,000 other people. So let's talk about the specific data sets. So the Zillow data set, which is the primary data set, has only 3 values when it's all said and done. It has the year, it has FIPS, which is a categorical descriptor of counties in the United States. These are actual strings, but they're numbers, but they're numbers that are based on the state and then the county. And then the most important value is the value variable, which describes in dollars the median house price of houses in that county. For the time period that I picked, which is 2010 to 2017, there are 22,720 records after reshaping, and then not all of those records had complete values. So the data set for Zillow had 21,000 records. For this data set, any records that don't have a value or don't have an FPS or don't have a year are dropped completely because there's no value to try to impute on this particular data set. For the GDP data set that's coming from the Bureau of Economic Analysis, you can see on the right-hand side, there's about 30 or so continuous variables. All of these are in thousands of dollars, and all of them represent GDP or economic production of a given sector for that county for a given year. This data set is the one that probably has the most what can be considered loss or the missing values, in that not every county has or at least reports every sector of their economy. So there's a handful that were missing up to about 25% of their variables. So they just had no number for maybe construction or utilities. So instead of trying to impute, those records will be retained, but they will be any null values that were missing will be replaced with a value of 0. So that will just assume that instead of reporting nothing, that they just had no industry in that sector that was worth discussing or worth mentioning. So that's how that will be treated. For an economic profile data set, This is one of the more varied data sets throughout the analysis. So you have personal income, which is not split up per capita, but there are also personal per capita personal income. So this data set has had about 28,000 records, and actually there were no missing data in this whole data set. And then the final data set that I have is a population data set from the USDA. It is just counts of people. So you'll be able to get interesting things such as the number of births in a given county in a given year, the deaths, the natural increase just from births minus deaths, the international migration and domestic migration, so between states, from states to other states. And let's see, this had 28,000 complete records. So the tools that I'll be using, opened up all of the data sets in Excel initially. This was just done to give a brief inspection of the data. When I was looking for data sets, I did find some that were too large to open Excel, so more than 1 million records, or were just too distorted to use. So this was used to do some initial screening, looking, and picking of data sets. There were a couple of these data sets show up as an Excel file, and as such, they've got some extra formatting that was removed manually before saved and it being imported into pandas. Python and pandas and that library will be what I do a majority of my data work in. It's relevant to my current position, and it's a skill that I'm looking to develop a little bit further. Statistical analysis will be done using the pandas library. Plots and maps will be generated using Matplotlib, Seaborn, and the Plotly library. And for future work, I'll be looking to build probably a linear regression tree, some support vector matrices, and along the look, see if I can get a neural network up and running for my 3 models. So I have experience with using scikit-learn, which is another Python library, and to a little lesser extent, Keras. I'm still on the fence about whether or not I'll be using TensorFlow to build a model. The final data set, when I merge on county and year, is the linkage between the 4 data sets that will be used. And when that's already been accomplished, I've got 21,071 unique observations that have they all have Zillow values, and they have all of the other 3 data sets as well. So that does meet the 20,000 record threshold. There are a total of 2,788 unique county regions. I'll show you a map here in a second of what that looks like. The time range is from 2010 into 2017, and the limiting data is really the Zillow data set. This map was generated in Plotly, which is one of the libraries I talked about in Python, and this shows graphically all of the counties that are in the Zillow data set. So you have very good coverage on the East Coast, West Coast, and pretty much east of the Mississippi. There are some counties that don't exist that much in the middle of the country. So it's where you kind of have lesser values, where not a whole lot of economic activity is going on. So this could impact the data set a little bit, but for the scope of the exercise, I think it's nothing really to worry about too much. An additional addendum: this is limited pretty much just to the 50 states. So no Puerto Rico, no Costa Rica, not Costa Rica, no territories, no Guam, no American Samoa, and that's why some of my data sets had 28,000 records, while the Zillow data set only had 21,000. Is that when you start adding those extra territories, the number of records increases kind of substantially. This is more of a breakdown of the high-level overview. So each of these data sets have FIPS and year, and that's what they're all getting matched on to be unique. And the value is the value as by Zillow Median Home Price Index is what I'm targeting to model. So that's references and any questions.
So Kevin, you're talking about like 29,000 counties or something, right? So volume of data would be like really high. Is that one record per county or?
So I've got
Is per
21,000 records. It is one record per county per year.
oh, okay, okay. All right. Looks awesome.
Thanks. Any
Hey, Kevin.
questions? Sorry.
Sorry, I do have one question.
Yeah.
In light of the growth with Amazon here in our area, I'm kind of curious in terms of if you've got a way to potentially capture such when certain areas get a large boon from an employer, and how long it would take then for the housing market to adjust, or which I imagine probably is more the case of the housing market probably adjusts in anticipation of the increased value rather than the other way around.
And it could. That's actually a real great point. Is that I mentioned a little briefly that this is a limited scope, right? I've got 80 variables, and this is after I threw away more than half of the data sets that I was hoping to put in there. I think the first initial cut, I had something close to like 400 continuous variables that all were talking about things that could impact the housing market, but just scope creep is too much, and it's only 12
Sure.
weeks, so.
Right.
But in terms to whether or not housing leads or follows is actually kind of again, it's complex. You talked about Amazon in the DC Virginia area. However, the opposite example of that would be something like the shale gas boom or SpaceX in Texas. Within the last month, doubled the amount of people that they hired. So
Right.
that wasn't something that was announced in advance and saying like, hey, by the way, we're going to go do this. Everybody come here and then we'll work it out. It was no, we need to do this now. So figure out how you're going to get here, figure out where you're going to live, and we're going to go do stuff. So I think there's a couple of national companies like with Walmart or Amazon is a very excellent example. If you say we're going to put 50,000 people in this location, and this is the timeline for it, I think that's a very different scenario than somebody who just happens to catch on to success and runs away with it. So
Sure. No, that makes sense. Now I didn't catch. Do you see any potential differing models per segmentation in terms of location? So like West versus East Coast, for example, or Midwest.
So the data set is split up by strictly county level. I could work, but the FIPS number is pretty nice to work with. Each state is given its own two-digit. The way it works is you have 2 digits for the state and then 3 digits for the county. So
Right.
like and then it basically starts Alabama. So Alabama, the first county in Alabama is FIPS number 10,001. The second county is 10,002. And then I think Arkansas is the next state, or no, Alaska probably would be 11,001 and 11,002. So I could group that back out. At this point, I don't have any plans. It's really more of a who stands out
Sure.
the most. So part of why I am pushing so hard to get map graphics up is that I think that will probably be an easier way. If you have several counties located next to each other that have stand out a particular way, visual inspection of a map might be the easiest way to capture some of that. But it's definitely something to look into more.
I'm curious to hear that a little bit further, because it's one of the things I'm running into with the multitude of courses that I have. I'm like, I really don't want to create a ton of dummy variables, but I'm not really sure necessarily how to, when you've got over 1,200 values for a categorical variable, what the proper way to to model it is.
Yeah, that's definitely a very hierarchies sound like your friend to a certain extent, but that's just a lot of variables, especially if they're not ordered. One of the pros on this is that everything I'm dealing with is continuous variables except for like the county name. So except for the target, the location itself is categorical, but everything else in my data sets are all continuous numbers.
Ah, very nice.
Yeah.
Good job.
Go ahead. Sorry, Brad. Go ahead, Brad.
I'm good. Good job.
Right. No, it's really awesome So I know that you're using Python, but where are you storing the data? What?
So I downloaded all of the data sets came in either as Excel format or CSV.
Okay.
And so basically you read them into Python and store them as a data frame object, and that's pretty efficient. So my outputs for this project will, when I merge them all into one flat table, it gets saved as a CSV, and then that way I can reload that CSV. It's got all of the variables. It's cleaned appropriately and all that stuff. So
Interesting.
does that answer the question you were looking for?
Yeah, it does. It does. I was wondering because that's really good. All right. Thanks, Kevin.
Cool. All right, I'll turn it over to you.
All right. Let me know if you guys are able to view it.
Yep, I can see you.
All right,
Sorry, I can see your presentation.
Yep, you're good to go.
All right. So my